Hello everyone, welcome to this video. Today we are looking at application of derivatives. Let's begin with the first example here. So here in this example, we are asked to evaluate these two limits algebraically. So we are going to work on A first. So in part A, we have limit as x approaches to 0 of 1 minus cosine 3x over 7x squared. First step in evaluating the limit is to try direct substitution. So if you try to plug in x equal to 0, in the numerator it will be 1 minus cosine 0. Cosine 0 is 1. So numerator becomes 1 minus 1, which is 0. And if we plug in 0 to the denominator, 7 times 0 is squared, that is also 0. So what we are getting here is if we plug in 0, we are getting 0 in the numerator and 0 in the denominator. So 0 over 0 is undefined. So we get this 0 over 0 form. And what we know is if we get 0 over 0 form, we have to use L'Hopital's rule. That is, we have to find the derivative in the numerator and denominator. So this will be same as the limit as x approaches to 0 of, now we'll find the derivative. Derivative of 1 is 0. Derivative of negative cosine 3x is 3 sine 3x. And then divided by, in the denominator, the derivative of 7x squared is 14x. Now we'll try direct substitution again. If we do that, denominator will be 0. And in the numerator, it will be 3 sine 0. That is also 0. So still we have the 0 over 0 form. So meaning of that is we have to use the L'Hopital's rule again. So limit as x approaches to 0. If we find the derivative in the numerator, derivative of 3 sine 3x is, so the derivative of that will be 9 cosine 3x. And in the denominator, derivative of 14x is 14. Now, if we try direct substitution, denominator is 14, numerator will be 9 times cosine 0. Cosine 0 is 1, so 9 times 1 is 9 over 14. So I'm getting 9 times 1 over 14, which is equal to 9 over 14. So we're able to find the limit of this first question using L'Hopital's rule, and we use L'Hopital rule 2 times. And the final answer is 9 over 14. Okay, now let's move on to part B. Okay, let's work on B. So in B, our question is limit as x approaches to pi over 2, 2 tangent x over secant squared x. We'll try direct substitution. If we plug in pi over 2, the numerator will be 2 tangent pi over 2. That becomes infinity. And also the denominator, if you try to plug in pi over 2, that will also be infinity. Secant squared pi over 2, that's also infinity. So we are getting infinity over infinity form. So if we have infinity over infinity form, we'll use L'Hopital's rule. That is, we'll find the derivative in the numerator and denominator separately. The derivative of 2 tangent x is 2 secant squared x. And in the denominator, we have secant squared x. So the derivative of secant squared x will be, but we use the chain rule there. So first we have 2 secant x, and the derivative of secant x is secant x tangent x, secant x times tangent x. Now let's simplify this a little bit before we plug in the value. In the numerator, we have 2 secant x, and also in the denominator, this is 2 secant x. So these 2 secant x will get canceled. So we cancel that 2 secant squared x and this 2 secant squared x. And by canceling that, we get limit as x approaches to pi over 2. We get tangent x in the denominator, which is same as 1 over tangent x or cotangent x. And cotangent x is same as cosine x over sine x. Now we can perform direct substitution here, because if you plug in pi over 2, cosine pi over 2 is 0, and sine pi over 2 is 1, and 0 over 1 is a 0. So that is the limit for part B. And here we use L'Hopital's rule to evaluate that limit. Example, using limits, find the equation of the vertical and horizontal asymptote to the graph of the function f of x equal to e to the x over x. So here we are looking for the vertical and horizontal asymptotes to the graph of the function. And our function is f of x equal to e to the x over x. Now, if we look at this one, in order to find the asymptote for the first part, let's do this. Let's try the vertical asymptote. Here our function is e to the x over x. Now let's see what happens when x approaches to 0. Limit as x approaches to 0 of our function e to the x over x. Okay, if we try direct substitution, e to the 0 is a 1, and the denominator goes to 0, so that becomes 1. That becomes 1 divided by 0, which is equal to infinity. So what we are getting is, meaning of that is, as x approaches to 0, you can see x approaches to 0, this function approaches to infinity. Function approaches to infinity. And what we know is, when we calculate the limit as x approaches to finite value, and the limit is infinity, meaning of that is x equal to this value here is the equation of the vertical asymptote. So this implies equation of a vertical asymptote is x equal to 0. So we got the equation of vertical asymptote. Now next one is we have to find the equation of horizontal asymptote. That is, we have to find the limit when x approaches to positive infinity and negative infinity. So let's first try positive infinity. Limit as x approaches to positive infinity of e to the x over x. And we can see that if we try to plug in infinity in the numerator and denominator, that will be infinity over infinity. So we can use L'Hopital rule to evaluate this. So this is same as limit as x approaches to infinity, derivative of e to the x is e to the x, and derivative of x is 1, so it becomes e to the x only. And the limit as x approaches to infinity of e to the x is infinity, because when x approaches to infinity, e to the x approaches to infinity. So here what is going on is, when x approaches to infinity, the limit is also infinity. If this value is finite, we'll have the horizontal asymptote. But in this case, there is no horizontal asymptote. So here we have no horizontal asymptote. No horizontal asymptote. So that is the case when x approaches to positive infinity. Now let's try when x approaches to negative infinity. Limit as x approaches to negative infinity of e to the x over x. Same thing, we use the L'Hopital's rule again. So we get limit as x approaches to negative infinity of e to the x. And what we know is, as x approaches to negative infinity, e to the x approaches to 0. So here we are getting, as x approaches to, let me write this, as x approaches to negative infinity, function approaches to finite value 0. Okay, function approaches to finite value 0. So meaning of that is y equal to this value 0 is the equation of horizontal asymptote. So this implies equation of horizontal asymptote is y equal to 0. So this is how we can find the equation of the vertical and horizontal asymptote to the graph of the function. So always we need to remember that we look for the infinite limit for vertical asymptote, whereas for horizontal asymptote, we have to find the limits at infinity. So vertical asymptote is the concept of, one more time, this is the concept of infinite limit. Okay, infinite limit. That is, we check when is the limit infinity. But this one is limits at infinity. Limits at infinity. If the limit at infinity is finite, then there we have the horizontal asymptote.